Hello everyone, I'm Adipol from JBCA Manchester. I'm a PhD student supervised by Redbacks. And today I want to present to you the optical study of the TRAPUM pulsar and the modeling results of the Redbacks J1036 and J1803. You heard from class that the Fermi large area telescope has been collected gamma ray photons for since 2008, and the current version of the catalog contains more than 7,000 gamma ray point sources. And you can see from this pie chart, some of them identified with extragalactic sources, but a large portion over here are still unidentified. Some of them been identified with like various survey, but here is our survey. We compare their gamma ray spectral property with the known pulsar and found that some of them are quite similar. So we selected 79 of them to search for using L-band of meerkat to point at them twice for 10 minutes. And you probably heard from many earlier speakers about how good meerkat is at searching pulsar. And okay, so I will skip this. Okay, and we formed the tire array beam that can cover like typical 3 sigma localization of gamma ray sources. The green dashed line over here to minimize the chance that radio counterpart will be missing from the beam. And we also use CCAT to improve the localization. Pulsar normally do appear in several beams nearby where it actually is. And so we use the signal distribution from each neighboring beam to triangulate the actual location. And this is like the results of that triangulation in this localization, which is about around a second. This is an example for J1826, which is very helpful for optical counterpart identify later. And the survey found 9 new millisecond pulsar. One of them is isolated MST, and the rest is in binaries. For the pulse profile here, the black is the pulse profile in L-band, and the red one is in UHF. We plotted the orbital period against the minimum mass. As you can see, 5 of them fell in the region of wide above MSP binaries, while the rest, 1036, 1803, and 1526 is in the region of Redbacks. The detailed report about the survey is published in Clark et al. 2020 under this title, and we already submitted the radio campaign and the gamma ray campaign by Martha and Lars, and the TRAPUM collaboration view has already been submitted. And the optical result will soon later. And this and after the pulsar discovery in radio, we use the ultracam at NTT to do the optical follow-up, and these is the images of the sources for the 8 binary, and some of them got the potential counterpart within the CCAT localization, like among this, and also some of them the localization is quite good. And this is the result. Even though we expected that 1526 to be Redback, but we couldn't detect any counterpart in the localization ellipse. And we also checked the nearby sources, but we couldn't detect variability from the sources as well. But we do detect variability from 1036 and 1803. And this is the HR diagram of containing the Gaia sources in the background, and this is the sun. Each that line is representing the detection limits of outer cam at that distance. The sources above that line is detected at that distance. So as you can see, like only bright star will be detected beyond at that distance. So for the sources below each line, they are less likely to be picked up by outer cam. So for the sources that we don't detect, like the potential counterpart, we plot the upper limit of the position that should be on the HR diagram. But for the Redbacks, 1036 and J1803, they were well above the detection limit for outer cam that we use the infer distance from the modeling, optical modeling. And yeah, for the upper limit of the, we obtained them from the radio timing campaign that they got this distance. Okay, about the redbacks, even though they both are redbacks, as you can see, their light curve are different. 1036 have the asymmetric double peak light curve, and J1803 have a single peak light curve. For J1803 in particular, we have 3 observation blocks, and each block have like each epoch have about a month apart between them. So we found this discrepancy between the light curve and And then we took to model this light curve. We use equals to synthesize the light curve and also the radial velocity curve. And we also study the pulsar irradiation using 2 prescriptions of gravity darkening. The first prescription is to resemble the shallow heating that the heat. Most of the heat, pulsar irradiation energy deposited above photosphere. And the other prescription is the deep heating that most of the heat deposited below photosphere. And the benefit of having radio ephemeris and also gamma ray ephemeris to combine together, and the radial velocity curve and also the photometry data, we can then constrain the component mass and the pulsar mass and also like the orbital inclination. Yeah, and also like study the irradiation effect on the component. Oh, okay, about the model, sorry. The model, we fit both of them with the canonical direct heating, and also to account for asymmetry on 1036, we fit them with convection and diffusion convection model and the spot model to account for this asymmetry. And for J1036, we found that the J1036 data favor the deep heating model. The shallow heating model is fitted to the data, but as we apply the wind to move the wind actually move like the exterior surface, the lower temperature region from around the nodes of the star and the night side to the side, this creating the phase offset in the light curve. So yeah, it means the shallow heating model will never fit as good as the deep heating model. This suggests that the most of pulsar irradiation energies is deposited below the photosphere. And for 1803, to parameterize the change over like the 3-month period of the observation, we fit the data with different combination of 3 parameters, which is the base temperature, the irradiation temperature, and the inclination, the Rochlot filling to permit to find the cause of the change. And we found that the best fit model is the model with different Rochlot for each epoch. This implies that the change in the brightness between these epoch is coming from internal structure of the star. It could be because of the evolution of the star. And for the plot on the right is the perimeter of the redback, and comparing to the transitional millisecond pulsar in the pulsar state. We found that the Rochlot filling of these two sources are higher than our companion here. And so we think that if the initial Rochlot filling of J1803 was as large as that of the TMSP, it could have triggered the mass transfer and form the disk. And that is the summary. Out of 79 sources, we found two redback companion and the one isolated NSP, and the rate we expected them to be wide of millisecond pulsar binary. And yeah, 1036 suggests that the most of the energy could be deposited below the photosphere, and then the radial variation in J1803 suggests that, okay, there. Thank you for your attention.
Right, so it's time for a question. Anyone has one? You can, Lucy first.
We tried this model with other redback as well, and the results suggest the same. Mm-hmm. Yeah, but to associate with the physics behind is still in. Yeah, this is change the order of the calculation between applying the irradiation and the gravity darkening. So it leads to this result, but we still looking for the answer that could explain better than the energy. But we've seen from some other simulation as well that they expect that the energy deposition could be below photosphere.
Right, thank you.
I think
if you also, yeah, the error bar is usually 0.1, 0.2 solar mass. But if you include also the entire spectra, you can even more accurate constrain the pulsar mass from this. But the main problem of our model also depend on the irradiation model, because that will affect how we constrain the inclination.
Thank you.
right, I think it's okay.
Yeah, we try to do that as well. Yeah, and also in the paper by Mark Kennedy for J1555, he's used the entire spectra and compare them directly to the result from Icarus, and that can constrain the mass much better than our result. line. Oh, we for the radio velocity we use magnesium B. But yeah, and for the upcoming work we also using like entire Balmer series.
I think it's time for the next speaker. So thanks Adipol for